So for our installation, we wanted to play on this idea of the illusion of control. We wanted to create a puppet that when a user walks up to, they think they have full control over it, whereas unbeknownst to them, there's a timer that sets only a certain amount of time that they can control the puppet. Then after that, the puppet takes control of you, putting you in the place of the puppet. This kind of plays on a metaphor of corporations owning your data, and this idea where you believe you're the user, where in fact a lot of times you quite literally are being used by these corporations. So now I'll just run through our Arduino code. The beginning is just initializing all our sensors. We've a block of code here that sets up our MPU 6050s, so they're ready to go. Our void setup is simple as well. We just initialize, again, we call all the sensors we'll be using and attach them to certain pins. In our void loop, we have a button press detection. So we wanted to find a way to debounce the button so everything still continues once the person has lifted their hand off the button. So once the button press is detected, millis is called. So this acts as our timer for the code. Timer active is then set to true, which will be used further down in the code. And we also send a serial print to max, which will link both of the codes together and they will be in sync. So moving on then, so if timer active is true, in other words, if the button is pressed, the accelerometers will map to the servo motors above, giving the user control of the puppet for 20 seconds. Then, once millis detects that the 20 seconds has elapsed, the mapping of the MPU 6050s to the servo motors stops, and we send the specific angles to both motors, causing the puppet to point at the user.
Okay, so just to get started then, working through the max patches. So this first one here is mainly serial communication between Arduino IDE and Max MSP. So we have it set up here to react to my serial C port at 9600 baud rate. Once it receives the raw data through from the serial port, it'll select out the 144, which is ASCII code for a comma. So it selects out the comma that has been printed from Arduino, and once it finds it, it sends a bang. So in our case, this bang here leads to a 1, which will inevitably turn on a toggle for our timer. Here's what the timer looks like counting down once the button has been pressed. If we look in behind the code for this timer then, we'll see that it's actually quite simple. So this is the toggle here that gets activated by our bang. Once this bangs, it also full screen fronts this patcher, which essentially means that it switches the window. Down here then we have our actual counter function, which is essentially counting from 30 to 0 in increments of 1 every 1000 milliseconds. We have a couple of outlets here, the most important one being our select 10, which essentially sends a bang once this timer reaches 10. The bang then gets sent over here. Once a 1 is selected, so essentially when the bang happens, it sends another bang down here, which sets up a second timer. Basically the exact same to the first, only this time it's counting from 10 until 0 rather than 30. Once this hits 0 then, it bangs back up here and resets everything back to 0. Moving on to the camera window then, this is the main display that the users will see. Obviously this black box here will feature the camera footage that is coming in. This is our little timer that we just discussed there, which counts from 10 until 0. Looking in behind this window then, we see our main timer over here, which is our 30-second dance timer. This is the timer patcher that I went through earlier. This patch is essentially a lot of bangs depending on time. So as we see down here, when this timer hits 10, it also bangs to multiple different objects down here, one of them being our audio, another one making it switch from the timer window to this window. This is our camera timer again here, which is essentially counting down from 10. Once it hits 5 though, it'll switch the device input from the first option in the menu to the second one. Once it counts down further to 0 then, it sends another bang to multiple different objects, one of them being the buffer again, and multiple others being things such as our toggle up here, which essentially toggles on and off our JIT.grab, which powers our JIT.p window. That's essentially it then for the max patch.
So moving on then to the fabrication section of our installation. We built just a wooden frame surrounding the puppet to create the stage, added a bit of fabric and thumbtacks to give this puppet show feel to the installation. We move up then to our wiring. We kept it pretty simple, stuck breadboards down, kept the wiring very clear so we knew where everything was, so we could go back and troubleshoot when wires came loose or something wasn't working. We'll move on then to our servo motors. So as you can see, we extended the arms just a bit to give our puppet a bit more leverage as the user controlled the accelerometers. Moving then down to the puppet, so we attached him just with fishing wire to make him look almost like he's moving alone. We got our puppet from Thingiverse, 3D printed him, and we glued fabric just to his joints so he's got this like nice dynamic movement to him. Moving on then to our accelerometers, we 3D printed handles just to encase them in to make it a bit easier to hold for the user, and gave him notes just so they make sure they're mapping the servo motors correctly. Finally then, moving on to our button box. So when this is pressed, the user is ready to control the puppet for 20 seconds. It just keeps it nice and neat and prompts the user to press it. Then the wire just feeds back up simply into our breadboard.
And now let's demonstrate how it works.